It's not a problem of Windows 11 or 10. It's not a problem. See, I'm using Windows 11. This is my Windows 11. Okay. And this is my virtual box. This is virtual box I installed. Virtual box 7 you do. Okay. Instead of 6.3 or 6.1, install virtual box 7 and install Ubuntu 22.04 or 23.04. Any one you can do. So just configure it and then you can install Ubuntu. Yeah,
Yeah, I have done in 11 only. According to the document, it works for me.
Yeah, it could work. Yeah. Okay. Okay, first I will be starting with the AWS instance, okay, because I have to show some remaining installation. Yesterday, like some remaining installation pending. So Spark and Kafka, okay, and Cassandra, Mongo, so those installations. So, so first of all, like how to create AWS account, okay, and what is AWS cloud services we are going to do in big data, okay. Okay, and we need to install this MovaXtram and WinSAP, right? If you want to transfer the files, so we need a WinSAP and MovaXtram I'm using for multiple tabs you can open. You can open the multiple tabs for like for PuTTY sessions, like terminal sessions, and then you can work. Okay, so you can do. So how to create account and those things I'm going to start. Okay. Or we do first Kafka. Okay. Okay. So AWS has some set of services are there. Okay. So AWS has the storage services. Okay. S3 is a storage service, and the file system and other EFS, Elastic File System is there. Okay. And EBS is there, Elastic Block Storage, that is internal for the AWS. Okay. So these are the storage services are there. SQL database service is there. So SQL database service RDS is there, and AWS has provided the Aurora. Okay, that is its own SQL database, and NoSQL database category. DynamoDB is there. So DynamoDB is a NoSQL database in AWS, and serverless computing. Serverless computing, we have Lambda, Glue, EMR. These are the serverless computing. So Lambda is like we can write any specific environment code. We can write Python, Java, and Perl, Ruby. So they are the different runtime environments are there. We can write the code without containers.
Arvind, EMR also serverless? It's a server based, right?
Server based, serverless, right? It comes. Voice system. Yes, server is there means like you are creating a cluster. Okay, but as a service, like it's serverless means like you don't need a deployment things like some Tomcat application server, like you are not deploying. Okay.
Okay.
So, okay. And Glue is a serverless, right? Basically, you are writing a Spark standalone code. Okay, you are writing. Okay. And data warehouse servicing. Data warehouse service is Redshift is there. Okay, Redshift is a data warehouse service. Okay. And analytics services. So analytics service like EMR, and this comes in the Glue. These are the analytics also. Okay, so these are the some set of services are there. Particularly when we are going to do big data with AWS. So and
what about Athena?
Yeah, Athena will come here with Glue and Athena, right? We can use dashboard query tool, right? And EC2 is like we can create EC2 machines like any operating system machines. We can create EC2. Okay, so once we create Ubuntu, right, EC2 machine, we can do the setup installation. We can do we can connect to the MovaXtram, and we can use WinSAP to transfer the file. If you have to do you have to run any job, we can use WinSAP to transfer the file. Okay. So if we are going to create an instance, so first we go to, okay, account is simple. Okay, I'm not going much on that because if you go to AWS, here you can find how to create a new account, sign in, and then you can create a register. So you can create a, you can register new account, you can register. Okay. So once you have login in the AWS, okay, so you can launch instance. Okay. And here you can give the name of the instance, which instance you are going to create. Okay. And here we can choose the instance. Okay. So if you are choosing, there are the different types of instances are there. Micro, mini, and there are the T2 micro. This is first is the which operating system you want. Okay. And then you have instance type. So they have specific RAM and memory, CPUs are there. Okay. So we can select the T2 medium is good for like when we are doing very high computation, then T2 medium is good. Okay. So T2 medium. So we can select and key pair. So key pair you can create, it's like for authentication authorization. So we can connect to the our EC2 instance using this key pair. So we can download the PAM file and then we can convert to a PPK file, that is a private key file, or we can use directly PAM file in the Mava Extreme. Okay, Mava Extreme can use the PAM file, but you are using PuTTY, then you have to convert PAM file to PPK file using the PuTTygen. So you have to install PuTTygen. Okay. So I have my already downloaded key pair. You can create a new key pair also. You can here you can create if you don't have the key pair. Oh. Okay. Into medium key pair. And all the settings you can remain same. If you want to get more storage, so you can define here the more storage. Okay, the disk is, and then you can launch instance. It's very simple, just you will get the your EC2 machine. Okay. So once your instance is coming here, when it is coming in the running state, so this is Mova Extreme. So how to connect in Mova Extreme, you can create a new session here and click on the SSH, and here you have to give the host. Once you get the public IP, you can use the public IP here and use the username Ubuntu. Ubuntu is a default username. And we have to give the PAM file. So here it is saying PPK file, private key file, but it can use PAML. So PAM file we can give. Okay. And here I have to give the public IP. So my Ubuntu is ready. Okay. So here I can copy this public IP. Then I can connect. Okay. So I'm right now in my EC2 machine. Okay. So whatever installation we want, we can do. Okay. So once our EC2 machine is created, okay, now I have to start the Kafka. Okay, suppose I have to do Spark Kafka integration. Okay, so I need a Spark, I need a Kafka. Okay, yes, I did Hadoop here. This is my another EC2 machine. I already installed Hadoop. Okay, so my Hadoop is there. This one. Hadoop fs minus ls slash Hadoop fs minus mkdir. Okay, so if I want to install Kafka, so how to go? So Kafka download, you go. Okay, go to the official website of Kafka. Okay, this is the link. So Kafka is like Kafka API is in the Scala. So either use Scala 2.20, 12 and 13. Okay, so we take it this one, copy link address. The font is good, or I should increase. Okay, so here is I have already software folder. So I will be wget So if you are doing everything in your local machine, so you have UI, right? You can easily do, right? You can extract and those things. Okay. So star XCF, Kafka. So I'm extracting it. Okay, so I can remove this tjet file. Okay, so cd Kafka. So I have to set the home path. Okay, so what is this path? This one. So I have to open the bash RC. So I have to go to home here, open the bash RC file, and I have to set Kafka home and Kafka bin path. So I have to set. So this is my Kafka home. And this, what is the version of Kafka? Export path, $path. Okay. Control X, Shift Y, enter, source, dash RC. Okay, so now I will be doing the testing of the Kafka. Okay, so how to test, right? I will be open the 4 terminal point, and then I will be doing testing for the producer consumer. Okay, so here you go to quick start. So once your Kafka is installed, so you can start the first zookeeper. So we have to open the 4 terminal. Okay, so first, this is in the bin, right? So I have to go to start the zookeeper first, because zookeeper is high availability for Kafka. Okay, so this is zookeeper started. Next is have to start the Kafka server. It's a broker, Kafka broker. Kafka we can install in Windows also. So this is the broker started. Next I have to start the producer. So, but before starting producer, I have to create a topic. So I'm creating a topic. The topic is nothing but a category of messages you can store in the Kafka broker. So generally Kafka is a messaging tool. Okay. So what is Kafka? So Kafka is a message broker tool, which is reading the data from the producer, and producer is sending the data to the broker, and consumer is receiving the data from the broker. So in Kafka, we have 3 major main component. Okay, producer, broker, and consumer. Okay, so zookeeper is there, but zookeeper is a coordination service which is providing the high availability for the Kafka broker. If multi-broker system, right? Sometimes how offset is basically the order the messages are coming from the producer to consumer. So and and sometimes high availability things is needed, and that is the zookeeper. But latest some version like Kafka has removed the zookeeper, so there is another option craft they have given. So there is no need of zookeeper. Okay, so producer is sender, which is sending the messages, sender which is sending messages to the broker, and consumer is receiving the message from the broker, consuming messages from broker. Okay, and broker is a server, Kafka server. Kafka server, which is storing the messages, which is storing messages, temporary storing messages. So there is a like it can store the message up to 168 hours. That is the default. 168 hours is the default, but we can configure it retention. This is called retention. So retention time we can configure. Retention time we can configure in the broker. We can configure for storing the messages. Okay, so we can increase or decrease. And broker is basically having a topics. Broker has topics. So topic is nothing but a category of messages you are storing. A category of messages you are storing. So suppose I say I'm storing the log messages. So I say info logs messages. I'm creating a one info log topic. Okay, info log topic. Okay, another topic is a debug log topic. So whatever topic is there, whatever name you want to designate, right? Your producer will be sending the message to specific topic, and consumer is receiving the messages from the specific topic in the broker. So broker has topic. Okay, so consuming message from the topic in broker. Okay, so both producer and consumer both are giving the topic name to read and write the messages from the topic. And further, topic has the partitions. Okay, so topic has the partitions. Like further, topic is divided into the partitions, and what is the use of this partition is like multiple consumers and consumer group can read messages parallelly from the partitions in the topic. So for parallelism purpose, we use partition. So there are the different partitioners are there also. Suppose how producer will be sending messages to the topic in partition. So there are the like custom partitioner, we can write hash partitioner. We have default partitioner. Default is a hash, but we can write our own custom partitioner. Hash partitioner is a default. Okay, and we can write our own custom partitioner class. We can write it. Okay, so Kafka has some producer consumer APIs code. Like we can use this producer and consumer APIs. Okay, either in Java, Python, different programming languages we can use. Scala we can use, because Kafka itself is written in Scala. Okay, and it is initially developed by the LinkedIn. Okay, so producer consumer API code we can write either of languages. Okay, so we can write producer API code, consumer API code, and then we can communicate. So that is programmatic way. This is a programmatic way to communicate. Okay, but this is generally used in the actual project. Okay, but when I want to test it, for testing purpose, we test on command line. We test it whether the producer and consumers are properly working or not. When I'm sending the message from the producer, it is received by the consumer or not. So for testing purpose, we use command line, Kafka, producer, consumer, message communication. Okay, so this is the other way is. And other Kafka has other different modules also there. Kafka has the Kafka stream. So Kafka stream is for the real-time data, near real-time data it can use, similar to the Spark streaming, but some differences are there because Kafka streaming can provide the transformations, join aggregations. There is a SQL queries we can perform on the data. Okay, and we can create entities. We can have a K table. So these concepts are there in the Kafka stream. But Kafka stream is not providing whatever all the features is Spark having, because Spark is providing machine learning and SQL database integrations, right? So all these things are there. So for that, Kafka has provided for SQL databases integration or another data sources, data you want to read in Kafka. So there is a Kafka Connect. So Kafka Connect is one API similar to the stream, which is reading data, different sources, and writing data to the different target through broker, through server. So source will be writing the data to the Kafka topic, and further the target will be consuming data from the Kafka topic. So Kafka Connect API, we can read from the data from MySQL and write the data to the S3 as a file. Anything we can do. So there are the connectors are there. So those connectors we have to use, and Kafka Connect. So Kafka, the Confluent is there. So Confluent has provided this libraries, right? This all Kafka registry is there. Kafka registry is used for the validation of the messages. So far there is no validations. This is if you are using Kafka registry and Kafka different types of schemas you are using, like Avro schema, JSON, right? So by default is Kafka messaging is in JSON format. But if you want to convert into Avro or other file format, we can do. Okay. So the validation purpose, we use Kafka registry. So Kafka registry is doing the schema validation. So these schema validation can be done in the Kafka registry. So these all set of you want to use in a one single place, we can use Kafka Confluent. Okay. Otherwise, whatever we are installing, that is Kafka, vanilla Kafka. It is a vanilla Kafka. We are using vanilla Kafka, which is Apache Kafka official version. Okay. But this, if you are using Confluent, so Confluent is giving a wrapper on this Apache Kafka, and they are giving their own set of tools they are providing also. Some more connectors for the Kafka Connect. Because if you are using vanilla Kafka, you will not get all the connectors. Okay, so if you want to use S3 connectors or some other cloud service based connectors, so you have to go Confluent. So there you will get more features. Okay. So here, okay, we started server, we started Zookeeper. Okay. Now I have to create a topic. Okay. So for creating a topic, so we have to give the server. Okay, so this is describing topic. This is a create topic command. So Kafka topic, create topic name, and then we give the server. Okay. Okay. Okay, so topic is created. Now I will start the, okay, so we can describe also. So how many partitions and everything, every detail it will tell about. Okay, so by default is a one partition, one replication factor. This is by default, but you can give more number of, like you can change this configuration parameter. Okay. So we can describe here. So Kafka has the leader and follower concept. So what is leader and follower concept? Like one is leader, one broker is leader, and other are follower. Okay. And one leader, the leader is down, the one follower will become leader, and then it will act till the previous leader will not come back. So it will become leader. Okay. So there is replicas are there, right? Like, okay, if I say Kafka is having replication factor. So there is ISR is there, in sync replica. So what is ISR? So ISR is basically like there are multiple, if you are using multi-broker system, then this will come in picture. Like where your one broker has some replication factor, you set the replication factor 3. So 3 replicas will be set in 3 different brokers, right? So how these replicas will sync with each other, right? So suppose your data keep updating, right, in the one broker. So your data should be replicated also in the other brokers also. So then in sync replicas is like doing this part, right? It is just syncing all the replicas data. So ISR is there. Kafka has different delivery semantics are there. What are the delivery semantics? So when the producer is sending message to the Kafka broker, right? So how we can make sure, right, like data is reached or not. So there are the 3 deliveries exactly once, at least once. at least once, and at most once. Okay. These are the different delivery semantic. We can configure it, or we can set it at most once. And Kafka has, when consumer is receiving the data, right? So what is partition assignment strategies are there? So there are the different types of partition assignment strategies are there. How the data will be assigned to the partition, right? When the producer and consumer is receiving data. So partition assignment strategies are there. The by default partition assignment strategy is sticky assigner. Sticky assigner is when I designating particular producer will write the data on particular consumer. So sticky assigner will be particular partition we can designate. Okay. But if I don't want to do this, I want to say like round robin. So round robin is like every partitions like 2 seconds time interval slicing will be there, and then the data will be received. So another one is round robin. And one is range assigner. So it is basically set of partitions in the range, right? It will be assigned. Okay, so range assigner is there. Okay, so next is I have created topic. Now I'm starting the producer here. Okay, I'm starting the producer. So how to start the producer? So there is a command kafka console producer.sh, and I have to give the topic, and I have to provide a server. So this bootstrap server is common, right, for producer and consumer. Okay, and we have to specify the topic. So which server? Here is only one server, but suppose I have a multi-broker system. So in multi-broker system, you have more than one server. So you will not be using the local host, you will be using an IP. So in that case, you have to provide a bootstrap server, and in that server, which topic, right? So you are sending the message. So you have to designate here, but sometimes I want to send a specific partitions also data, I can set with the partition. So I will assign the partition also, like partition 1, partition 2, partition 3. So I have some partition name in a particular topic, then I can designate. Okay. So here we don't have partition, on default partition only one. So we are not giving here, we are giving topic and the server. Okay. So my producer will start, and it will start receiving the messages. Now I can write the message here. But these messages are going to the server. Okay, if we check the server logs locations, right? So we can see. So if I go to the like server logs location, so where is my Kafka is there. So here the messages are updated. And when I want to read the messages, so I will give the consumer. So I will start the consumer. Okay, so here I have to start the consumer. So whatever I have given here, the beginning, right, from beginning. So I will not lose my messages. If I giving from latest, right, so only latest messages will come. When your server is up and consumer will start receiving, it will read the message when the latest messages will be there. But I have given from beginning. Now if I'm sending the message, this message will be received at the consumer. Okay, so this message is coming through the broker. Okay, so here producer is sending message to the broker, and the consumer is receiving the message from the broker. So this is a push and pull mechanism in the Kafka. Okay, so how to install the Spark? Okay, so I take it. wget. Okay, so if I check here, it's giving problem on Jet. Sometimes the issue is there. It's coming 29 kb. Okay, this link. Okay, this is the actual link. Okay, so don't do any mistake to copy that link and use. Okay, so this is the actual link. You understood, right? I have taken the outer link. That is not the main link. Okay. Okay. Okay, so now it is taking time. Okay. Okay. Okay, so X here. Okay, so I will set the home path of this. Copy. And HRT. Export. Start home. Start home. Enter source. I shall see. Okay, so now we test the Spark shell. So we are getting the Spark Scala shell, and you want to test the PySpark. So PySpark you can type and then it will come. Okay. So if I want to do the integration with the Spark with Kafka, right? I want to see the Kafka Spark streaming. Actually, when we are saying the Spark with Kafka integration means streaming module comes in picture, because Kafka is giving a streaming data. Okay, so Kafka is receiving the data some producer and writing to the topic. Kafka is and then Spark will become a consumer. So here, instead of writing our own console producer consumer, right, and I'm using a Spark consumer. So Spark will be my consumer. Okay, So I will be receiving data. So there are the two ways are there. So I'm just explaining about Spark streaming concept. Okay. So there are the three different modules, right? Which is a very important module. So Spark Core, Spark SQL, and Spark Streaming. Okay. Other two modules also there: Spark Machine Learning, MLlib, and Spark Graph. But these two modules, like very rarely used, right? If some machine learning project is there, data science project is there, then a machine learning library will be used. And Spark Graph is specifically used where you have data in the connected graph form, like Facebook. So you can find the user of users, like you can have ages, vertices, right? So when you have this kind of, so there is a graph DB is there in the NoSQL database. There is a NoSQL database New4j. Okay, so Spark Graph is specifically used for that purpose. So when I'm talking about the core, so core is a base module and it is providing the transformations and actions. Okay, so the mostly transformations, all transformations are here, and the three fundamental data structures are there in the Spark. The first data structure is RDT. So everything is on top of the RDTs. When we are talking about the measurement unit in the Spark is RDT. And RDT, and second one is a data frame. And the third one is a data set. So when I say RDT is a resilient distributed data set. So what is R for resilient? Means the data is a fault tolerant. Like data is fault tolerant means recomputed. Data can be recomputed, and it is maintaining a DAG. It is maintaining a DAG. DAG is nothing but a direct acyclic graph, which is forming a state of your operation, right? So when your any program you are running, right? So it is creating the RDTs. Everything is like starting from the RDTs only. First, you will be reading the data, or you are creating some data. So everything will be created as a RDT. And RDT will further, like you are doing some transformations you are doing. Suppose I'm saying first I'm reading the file, reading a file. After reading a file, you are doing map transformation. And map transformation, then you did flat map transformation, you did join, you did two data sets. Okay, so they're different. And finally, you called action. So action, like you are saying, save RDT into file. Okay, so you started RDT and finally saving the RDT. So RDT is basically a partition data which is distributed across the workers. Okay, like in Hadoop, we are saving the data, right, in the storage. But RDT is, this is all happening in the memory only, because Spark is not a storage system. Spark is not storing anything in the files, in the disk, right? Spark is processing everything in the memory itself. Okay, so when it is processing, right, so it is whatever the DAG is having transformations, it will trigger all transformations. It's a lazy. So Spark has a lazy evaluation. So lazy evaluation means like when you trigger action, then only your transformation will be performed. So basically it is not extensive memory consuming, right? So when you finally calling action, right, when you on demand, right, action calling, then your all transformation will trigger and final result you will get it. Okay, and sometimes like we can use the cache method. So if I have some RDT, I put it in the cache. So I don't need to store the data back to the disk and then again read the data. That is a thing in the MapReduce. But in the Spark, it use cache. Suppose you do rdd.cache. So once you do rdd.cache, your data will be stored in this RDT will be stored in memory. And for further processing, it will read from the memory, and then it will be faster processing rather than you are doing the input output disk handling. Okay, so but RDT has the persist function also. Sometimes I want I don't want to keep it all the time in the memory, because if the data size is more, right, so I cannot consume the memory all the time. So I can use the rdt.persist, and I have the options here. There are the 5 different persistent labels are there. So one persistent label only memory. So this memory only option is equivalent to the cache, but the other options are there: disk only, memory only, disk only. Okay, there are some constant are there. I'm just writing the name. disk only, memory and disk. What is the use of this memory and disk? Sometimes your data size is suppose 2 TB data, but your memory is suppose I say 256 GB RAM is there. Okay. And this 256 GB RAM, you cannot process all the data together, right? So you want to avoid the out of memory errors, right? Like if your data size is more than your RAM, so you can use this persistent label memory and disk. So how much memory is there, it will process the data, then further data like this, it will be doing the processing. So RDD.process and same data frame also having the similar transformations. So data frame is on top of the RDD is providing a tabular representation of the data. Okay. So RDD is completely unstructured form of the data. This is unstructured form of the data. Unstructured form of the data. So generally when you get the RDD, when you are reading a text, so when you are reading a text file, then you are reading a text file, then you will get the RDD because it's a unstructured. If I say this is a text file, right? And this text file, there is no like a proper column are not there, right? Like here is a 2 columns value, here is a 10 columns value. So this kind of text file, if you are reading, you will get the RDD. Okay. So when you are reading the text file, okay. But when you are reading the some structured format data files, like okay, when you are reading CSV, JSON, XML, Parquet, Avro, ORC, or SQL database, or any SQL database, or any NoSQL database, okay, you will get the data frame. Okay. So this is a Spark. So when we are saying NoSQL database, when we are using NoSQL database or any cloud, anywhere we can get like S3 CSV file or like these kind of files you are reading, you are getting a data frame. So data frame is giving tabular representation of the data in form of row and column. So here is a row are the records and the columns are your fields, right? So then you can easily manipulate the data because these are the columns, so you can directly apply your transformation. So same transformation, map, flat map, filter, join, group by key, reduce by key, you can apply on the data frame. And data set is further extension of the RDDs and data frame. Okay. And it is providing the encodings for the security, one encoding, like you can set encoder. Okay. And other than that, data set is type strict API. So here in the data frame, you will get not get any compile error if you giving a column name wrong. Okay, because it's finding the error at the runtime. But in case of data set, right, it's a type strict, right? Like entity based. It is an entity based, POJO based, right? POJO based or entity based, right? So it is giving you the compile time error, right? If you are having a column name wrong or something is you are having errors. Okay. So data set is an extension of RDD and data frame. It is having the features of both. Okay. Like unstructured as well as structured, both features are there in the data set. Okay. So these are the three data structures are there. So Spark core, we are using transformation and action, and Spark SQL is basically reading and writing data from the different source and target, reading and writing data from different sources and target. Okay. So that is deal by the Spark SQL. Another one is a Spark streaming. So I have a two types of data, like either a batch processing data or I have a real-time data. So when I say batch processing data, so this Spark SQL deals with the all the batch, right? Batch processing. And this batch processing is the same as the MapReduce. Okay. But Spark is giving another like real-time or near real-time data you can process, right? So that is basically through Spark streaming. So Spark streaming, there are the two types of streaming is there, D stream and structured streaming. Okay. So understand what is the difference between the D stream and the structured streaming. If you understand the RDD and data frame, so this D stream is nothing but is a sequence of RDDs. When your streaming is nothing but your data is coming in a sequence. Okay, it is itself is a batch only, but data is coming in a sequence, right? Data is coming in the sequence. Okay, and that is called the sequence of RDD is called D stream. Okay, so here suppose you are reading the data from Kafka, or you are reading the data from the sockets, okay, or you are reading the data from file system. Okay, in a, so you can use there is a separate methods are there, like there is no fixed function is there, like every has a, like if you are reading from the file, so file as a stream function is there that you can read. If you are reading socket as a stream, you can use, right? Okay, because you are reading from the socket. Okay, and Kafka you are reading is here is create stream function is there. Kafka util.create stream. Kafka util.create stream. So this function is there, which is used for the creating a D stream. Okay, and D stream is a sequence of RDD. But structured streaming is giving a unified single function, that is read stream for reading the messages, and write stream for writing the messages to the target. Okay, so when you say read stream, so you have to define the format. So you have to tell the format. So you say like, okay, I'm reading and writing data from Kafka, so my format will be Kafka. If I'm saying I'm reading and writing data from the socket, so I will define the socket as my format. If I have a file, file is a format. So you need to change just format. If you are reading and writing data on console, so console is a format. So you can read the data, not read, write the data to the console. So you can use format console, and then you can write the data on console. So structured streaming, one more benefit is there, watermarking. Watermarking is a concept that concept is not there in the D stream. Watermarking is, suppose your events are getting delayed, right? Your messages are coming delayed. So you will lose the messages. It is a synchronous kind of processing, right? So if the during the one batch you are not getting all the messages, so those messages will be lost. But in case of here is a some threshold time is there. So this threshold time is called watermark time, and you have to set the watermark time. So you can set Spark streaming context dot set watermark. So set watermark, you can set like a 2-minute time, like you can set it. So you can set like timing, you can set it here, like how many minutes, like how many seconds, like you want to like you can wait for the messages which are delaying. Okay, so threshold time is called watermark. Okay, and that we can set it. Okay, and another concept is there, checkpointing. So checkpointing is basically a feature which is there in the even the D stream and the structured streaming both are having checkpointing. So checkpointing is basically we are creating a one directory in our Hadoop file system which can store the messages if our server is down or our consumer is not up. Okay, so in that scenario, the checkpointing it is creating a buffer storage on Hadoop file system or S3, whatever you can give. If you are working on the cloud, so you will be using S3 as a storage for that. Okay, and directly to store messages if our consumer is not receiving. Okay, when consumer is up, then it will read messages from here. So you will be not having any data loss. You will. So it is called fault tolerance, right? In the Kafka Spark streaming, how can we do fault tolerance? So we can do this way, checkpointing we can implement from this directory. Okay. Okay, so I will be showing the structured streaming example. Okay, how to start the like a Spark consumer, and then how to read the data from the Kafka topic. Okay, so here So I have to use one minus minus package to start the, like if I want to read the data from the Kafka topic. So I have to start minus minus package. I have to give the connector. Okay. So I have to give one connector. Okay. So Spark shell minus minus package. So Spark SQL Kafka. So this is a Spark version. This is a Kafka version. 2.12 is a Kafka version, and this is a Spark version. So I'm just starting my Spark shell with this minus minus package. So another option is there when you are starting the Spark shell, you can use minus minus jar. So minus minus jar, and you can give your local directory location where your this Kafka connector jar is there. So if you don't have that jar locally, so you can use this minus minus package. So it will be using the internet location, right? So it is the repository location. It's a Maven repo location. It will be using this package minus minus package. So first I have to start my Spark shell with this package. Okay, we try 15. Paste. Is the Spark version? What is Spark version? Let's see this 3 point. Connector. Is something wrong in this? Let's here, let's see this minus. Minus jars. So minus jars. Okay, our purpose is solved. Okay, this package is not working, but this way, yeah. So we got it. Okay, so we have made it up. Okay, so now we have given the Spark shell with the Kafka connector jar. So either we can use minus minus package, or we can use if it is not downloading, so we can try this minus minus jar. So first of all, what I need to do for reading data from the Kafka topic. Okay. So I have to import SQL functions. And I have to create some data frame, right? A read stream format is a Kafka, and the bootstrap server is my local host. Okay. And option subscribe, I'm giving the topic name. This topic will be the topic where my messages are there. Okay. So I will take it my topic name. My topic name is quick start event. Okay. So I'm changing to quick start event. Here I will change the topic. So I will do I think all classes are not coming, because when minus minus package we use, then it doesn't get starting offset. Okay, so what is a class of this? We download the jar. Maven repo. So this is a Kafka client. Okay, this is a jar. So here I download this jar. Okay. Now I have a 2 jars. So I have to start again Spark shell. To go, I have to give another jar. Code is nothing, it's just very small piece of code. So first will come the Kafka version. So Scala version 2. I think this will come. This is the same thing. So here this is a different machine. Yes. To reconnect. You guys are getting my voice? Hello?
Yes, sir.
Yes, yes.
Okay, okay. Okay. I thought like it's something different. Okay. Yes. Okay, that's connect. Okay, let's start. We do Mongo, another one we installed. Okay. So Mongo we can install from the DigitalOcean one. Okay, so I followed this one for Mongo. We can. Okay. Yeah, no, it's fine. Okay, this is a Mango shell. Okay, so we can do practice on the Mongo shell. So I want to see the DBs, right? So these are the system DBs. But if I want to create some new DB, so use command is used to create either new DB. So what is the concept in the Mongo? Okay, just I go little brief on that. Okay. So when I say Mongo, MongoDB is a NoSQL database. Okay. Okay. And basically it is having like a JSON document. It's a type of JSON document oriented database. JSON document oriented database. So you can store as a JSON document in the Mongo. So Mongo has a concept of DB. So DB is a database, okay, and database has a collection. So collection is nothing but table. Okay, so in Mongo we don't call table, we call it collection. So we create DB, and inside DB we can create collection, and the collections have the document. So document is nothing but record. So this is a terminology in Mongo. So we have DB, DB has collection, collection has document, and then records we have the fields. Okay, so records will be fields, collection of fields. Okay, so this way we store the data in Mongo. Okay, so Mongo is not using any SQL. Mongo is using like its own commands are there. Like if you want to see all the databases, so show DBs is there. Okay, if you want to create a collection, so create collection command is there. If you want to create database is command is use command. So when you say my DB, it will create a new DB. It will create a new DB if DB is not there. If it is there, so it will use the existing DB. So it will create new. If it is not there, or if it is there, it will use it. Okay. So once we use DB, then after that we can do show collection. Show collection like a show tables. Show collection. You can see the how many collections are there. Okay, and there the commands are there. DB dot insert into collection. Then you can insert the record in the collection. So insert one record, insert many records. Okay, so those are the commands are there. Okay, you can follow tutorial points. MongoDB. So they have given all the CRUD operations. So like create a database, create a table. So use database, I told you, it will create either or it will create a new DB. So if you say here, use my DB, and now show DBs. So you will see, okay, it is not coming. Show DBs. Okay, so to check your current selected DB or not, so DB command is there. So which is your current DB? So your current DB is my DB. So you are in the current DB, and you want to create a new collection. Okay. So this is a collection. Movie is a collection. You want to insert some record document, so you can do insert command. Okay. So now if I want to create a new collection, so db dot create collection and give the collection name. So I can give like I want to create a collection. So simply you can give db dot okay. So show collections. My collection is coming. Okay. So this way you can do, and further more commands are there like drop collections and insert document. Like you want to insert the document in a particular collection. Okay. So I can insert the JSON document data. So I change it. My collection is movie. So I'm not defining any schema thing, right? So it's a dynamic schema. If this is a record is inserted. Okay, so I can use the find command to see the content query document I can do. Okay, so you can insert like record. Okay, first you create collection, then you can insert. Like I can create a new collection. I can create a new collection. Okay, and after that you can insert the record. So this JSON document data, you can write it. Find function is there to search the record. Okay, db.find, you can do find. Insert one record, only one you want to do. Insert one is there, so you can do insert one. Insert many, you can do many. You can do many. So you can do. So these are the functions you can use. Okay, maybe there's some. Okay, so when I want to do find query document, so find is there. So you give document db.collection name dot find. This is the and find if you want to specific column like feed, you want to find the record, so you can find, otherwise it will find all. Okay, so if I say db dot one, I created post, so you can see here post. Okay, so this way you can do. One pretty function is there. Suppose you want to make it in a proper formatted order, right? So you can use pretty. So you can use db dot. So whichever DB you are there, that will be your current DB. And then I'm getting the data from my post. So I have written the data. Okay. So, and other operators also you can use, right? Like equal, greater than. So you can use like db dot my collection dot find, and then you can give. Okay. So you can give the this operator, you can use like okay, less than, equal, greater than. Okay, so these are the, you can use and operator you can use. So you can use dollar and sign, and then you can give here two different and condition you can give. So it will get the result where these two values are matching, and condition, or means any one of them matching. Okay, using and or. So they are the different conditions you can give. Not, if that basically not keyword means that is a complement. Okay, so which is not there, like not in kind of. Okay, so this way we can do this all find. Okay, we can find the document. Okay, so then many more thing is there, like delete document, you can delete, you can update document, so you can do update. So update function is there. For delete is there, right? For delete document, so you can remove, and then you can give the delete criteria. So you can give the title based, you can remove only one, only first record, whichever first occurrence come, the first record it will delete. So this is a way of deleting the document. Projection means, like, suppose a specific field you want. So projection is nothing but in the find, you don't want all the fields. So you want a specific field, you say. So you will be giving the title I want and the ID 0. So I can specify the projection. So I can define the projection. Limiting the number of records. So limit is there, then you can define the limit. So sorting you can do. So sorting function is there, sort, and then ascending, descending. Okay. So example will display the descending order. So -1 for the descending, and default is so you can change the order. So you can use either -1 or +1. Okay, so these are the indexing. Indexing is basically used to making your data faster retrieval, right? So you can create the indexes. So create index, you can create on a specific column. You can tell about the column on which you want to read the data. To create index. Aggregation. So aggregate function is there, like when you are doing the aggregation, sum, join, right? Something you want to do. So you can do the aggregation, right? So aggregate function you can use, and then you can give the aggregate operations. So suppose you have this data, okay, and you want to group, and then you want to count function you want to do, or you want to do the sum. So you can do like aggregate function. Okay, so these are the replication is the multiple copies, right? You can replicate the data on the different nodes, so you can use the replication. So these are mostly admin related concept, right? When you use MongoD utility, and then you can provide the replica set. So these things you can do. Okay. Yeah, please turn off video. So these are sharding is basically replication of the data, right? It's a sharing the backup, right? It's a sharding is backup, right? So we can have multiple servers, right? And we can create a shard. So Mongo is providing the shard basically. Okay. So next I install Cassandra. Okay. So for Cassandra is also NoSQL database. It's a key value pair database. Okay.
Sorry, sorry, excuse me, which command to present the data result in a table that we can
Where you know which database?
in Mongo DB
What
collection to present a collection in a table form in table form.
Okay, collection is show collections, right? We do.
Does
Show
it show,
collection will show you your like all collections.
does it,
You are saying like whether a collection exists or not exists, like this.
no, if it exists, you know, because the way it presents it is difficult to understand for me. Does it present it in tabular form like we're used to?
Tabular form, no. Actually, this is
No, it doesn't.
complete
It
as a
doesn't.
JSON document oriented database, right? So it is storing as a dump is the doing database. It's nothing using SQL. Okay.
Oh,
So
okay.
yeah, so it's not a tabular, right? So we are dumping data, right? We are, and it's a dynamic schema is there, right?
It's a different concept.
Yeah, it's not following the SQL. It's following the cap. If you see, Mongo is cap theorem. Okay, consistency, availability, and partition tolerance. Okay, when we say cap, consistency, availability, and partition tolerance, so they are the all NoSQL databases having the category. Okay, if I say in which category this NoSQL falls, so at least two properties should be followed by any particular NoSQL database. So Mongo is following CP, consistency, and partition tolerance. And HBase comes also in this. Redis is the in-memory management database, like it's an in-memory management database. Redis key value pair. HBase is a column family. Mongo is a JSON document oriented. Cassandra is a key value pair. DynamoDB is a key value pair. React is a key value pair. So these are the different type of categories. One is a JSON document, one is a column family, one is a graph DB. So they are the different categories. So which category NoSQL fall and which property it is following. The two things is important, which category it comes and which part of the cap it follows. Okay. So any NoSQL database should follow at least two properties. Two property it will follow, then it will be called NoSQL. Then it will be a NoSQL database. Okay. So Cassandra, Mongo, all these are the NoSQL databases because they are sharing data across the machines but Cassandra is a peer-to-peer architecture. Mongo is master-slave. Mongo is master-slave, like it's having master-slave architecture, but Cassandra is not master-slave. Cassandra is peer-to-peer, right? Every adjacent node in Cassandra has the information about the adjacent node. Okay, so Cassandra is peer-to-peer. Okay. So like depend on which database, but Cassandra is using SQL query. If you see, I'll show the Cassandra. So Cassandra is completely SQL. Okay, Cassandra DB. So it is doing SQL. Okay. So Cassandra is the data model, right? It is using, but Cassandra has a key space. Here the database, we call it as a key space. So key space has the replication factor, replication strategy. So we are creating a new key space, like we are creating a new database, create key space name with replication, because data is shared across the machines, right? With the which class, right? There are the different class are there. Assign simple strategy or network topology strategy. So there are the different types of strategy is there for the replication, and what the replication factor you want to keep it. So you will create a key space, and basically here you will be defining the tables, and then you will be defining the table having the columns, and this is the similar to the SQL.
Right.
Okay, but one more advantage is there in Cassandra. It is supporting the collection. You can write the as it is collection, like in Hive, we can write map, set, list, right? So same thing we can do in the Cassandra. And Cassandra, we can create our own custom data type also, CQ, like these are the default data types. But if I want to create my custom type, okay, so you can create your user defined type. I can create my own type. Like suppose I have a credit card. So credit card type I can create because credit card has the number, credit card has expiry, okay, name. So these are the set of information. So when I know this set of information are related to credit card, I can create a one type is credit card. And this credit card related object I can create in the Cassandra. Okay, so that is the very good feature, right? That is a create custom type, right? I can create my own data type I can create. Okay, and then I can use it. Okay, and it can use the list set map also, like you want to store the data as a list. So there is no relationship concept is there in SQL. Suppose you have a parent child, right? You have a one class is a parent and child, then you have a primary key, foreign key relations are there. So here
Right.
is no relation. Same Mongo is not having the relationship, right? So Mongo is using embedded document. So one document has address, right? Like one person has address. So
Right.
it is nested document, right? So that's the advantage of like you are not having any join, right? You are not using at all any join, right? Because you don't have the multiple collection you are doing.
Relationship, yes.
Yeah, so it is inbuilt embedded collection. So it is using embedded collections. So list, set, map. Okay, so same thing Mongo also using the embedded reference it's using, right? Okay, one collection has another collection as an embedded reference. Okay, so you don't need to define any relationship in the Mongo and Cassandra. Okay, so Cassandra is a NoSQL DB, okay, and it is having horizontal scalability, those features, whatever any NoSQL database comes. And here in the Cassandra, if you see here, it lies availability and partition tolerance. So these two properties are followed as a CAP theorem in the Cassandra, okay, and it is using CQLSH. It's an on query language. It's called Cassandra Query Language, CQLSH, okay. So CQLS is similar to the SQL only. It's completely when you are creating a table, okay? When you create table. So what you are writing here, create table, table name and column name. So you are creating a table similar to the SQL, right? You are defining the primary key, but here you are using data type text. For string type of data, you have text. You have integer variant is there. So different like data types are similar to other SQL databases. Name
What
is
is
different.
what is the integer variant?
It's a like generally integer is a fixed value, right? But variable integer is like suppose your data is 2-digit, right? So it will accommodate not the default length. It will take it whatever length of your data you are accommodating. So varchar, in the SQL, that thing is provided the var int. Okay, so this is the variable size of the int value. Okay, and we can alter table, we can drop table. Okay, so first we see that how to install Cassandra. So this all integrations we can do with Spark. So once we have installed like Mongo, Cassandra, MySQL, then we can read data and then we can perform analytics. And then finally we can write data back to the Cassandra Mongo. Okay. So we can use it as a storage this NoSQL databases. So installation, right, when we want to do, so JDK we need, this is we have. Okay, so this is some package. If all installations are ready, then you can do practice, right? And you have a code setup, you have a practice code you have, and you have applications, all softwares are installed, then you can do all integrations. Okay, yes. Sometimes some installation can give the issue, but most of the times if you're following the same document, so if it is already installed number of times, so it will not give any issue. But sometimes the configuration issues come of the operating system, so that could be a problem. Okay, so this, and then this is a Cassandra. So here you remember this Cassandra is not C capital, okay? Otherwise it will say you module not found. It is saying, right? So this is C small. Okay, again, we got some issue here. So this one. This is a version it is not able to install. This is getting failed. Okay. I try to find. So it's missing. Okay.
Arvind, the Cassandra installation command you didn't enter it.
Which command?
Cassandra installation command. Sudo apt install Cassandra.
This one.
Yeah, that one.
Yeah, so still is giving the same package, this Debian package. It's picking up the default package in the repositories. That I think whatever key we are using, that key is the key here 40. I think this is the same 4x. Okay. Okay, if we go the little older version 3.1. think this version is giving problem. Point X will not give the problem. Here is 4x. Yeah, this one we have to do manually. Some key we need to add. This. Okay, rather than the spending time on this. Okay, so 10-minute break I then start the Jenkins and Git. Okay, so we will start that. Okay.
Okay, thank you.
Hi everyone. Are you able to hear me? You getting my voice?
Yeah, you can hear.
Yes. Okay. So actually in the chat GPT also steps are there. So you can follow this one actually, but still I'm getting issue of the previous the key is 4.x. But if you use it, this 3.x here, so this will be installed. So it will not give the problem. Okay. So if you follow this step, so this will work. Okay. Because 4.x has some issue. So mine is already, this key is stored. So I have to, this package I have to remove and then I have to reinstall from the start. Okay, so next topic, like, okay, in the DevOps, like we start with the Git first. Okay.
Excuse me.
Mm.
How do you uninstall if it has a problem to install the lower version?
Lower version of this one,
Any of
Cassandra.
them, any of it on Ubuntu, any of them, because the latest version seems to have problems in some of these packages.
Mhm.
If you want to install the stable one that's been established, how do you uninstall the previous one that you started that having problems?
Yeah, so that some package you have to do either manually, you have to do that will be also worked out, right? 4x also, but that some manual steps we have to do in the Linux. Okay, that we have to do.
That's the
Or
problem. In some of these installations, the latest version has issues. So I install the lower versions and it works, but how do I uninstall the ones you already started? I don't know. In Windows, it's not a problem. You can uninstall, but here in Linux, I'm not sure what to do.
Mhm. Yeah, latest version will also work, but if we find the proper steps, right, so it will work.
Exactly, but when it doesn't work and it takes too much time to debug and find out the solution, then you can take the one that works and move on. So
But 3.x is this one also not very older version. If you try with this 3.11, that is also everything you will get it, whatever you want to work with Cassandra. So everything is there in this version. Okay, so you can use it.
I know in Kafka, I have that problem. So how
Okay,
do I?
Kafka.
Yes.
Mm-hmm.
How do I remove the one I started to take the one that works?
Yeah, so we have to find some stable version, right? That should not be pretty old, and or those are the stable version. Then we can use those versions.
Yes, I know, but you started a newer version, but you are stuck. Then you need to remove it to install a new version, the one that is stable. So there's no easy way to remove it.
No, we can easily remove it. That's not
How?
a problem.
Uninstalling? How?
Uninstalling, remove the whatever the storage files you have. Kafka one is simple, right? Kafka is just simply you are setting the home path and you are just removing the Kafka directory, right? So you are getting a problem in Kafka. You are getting problem.
Yes.
Okay, I'll see that Kafka one. Okay, I'll see your issue. Okay. 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 Okay, first we start this Git. Okay, so there the two things are there, Git and GitHub. Okay, so when we are doing locally working, we are working on the Git. Okay, and GitHub is a repository. It's a remote repository where we have our code in the remote repository where we check in and check out we have to do. Okay, so we can use the Git locally, and the GitHub we use for the check in and check out our code, and then in the distributed environment we can work together. Okay, so how to start the Git, right? Basically, Git you can install in the here in the there is a simple sudo install Git. So it will install the Git, and then I can do any Git clone any repository. Okay, so I'm just creating one code in my local, and I will push the code into the remote repository. Okay, so first I will be creating some directory here, my project. Okay, so first I have to initialize. Okay, git init. So to make it, this particular folder, I want to make it as a Git specific. So git init command to initialize Git. Okay. So when we are starting with the Git, so Git version we can check. Okay, Git we can set our username and email we can set, like configuration we can set. Okay, so we can set it. And it's global. Which is associated with my Git account. I'm setting that email and the user, because later I will be using to commit the code in my repository. Okay, so I will get init to initialize. Okay, I'm creating some files. Okay, so one HTML file I'm creating. vi index.html.
So we can either use the VI or cat to create file.
vi
Cat or VI, either of the two, or they have a
cat is
difference.
just for checking the file, but vi is creating file, right? And or we can see the file also. Vi, if it is file is not there, it will create. If it is there, it will show the content. If I do again vi, so I will see the same file. Yeah. Okay. But cat is only for viewing the file. Okay. WQ is for saving the file. Okay. So I created a one file. Okay. Now I want to check my Git status. So it will be showing in the untracked file. So untracked file is not the stage file. This is not stage. So there are the different areas are there. First is the untracked area, where like you are not save the file in your staging area. Okay. And after staging, you will be committing the file and then you will push the file. So this will be Git status you are doing. So it is an untracked file. So you have to use git add command. Git add command, if you give dot, so it will take it all file. Or if you give particular only one single file is there, so you can do. Suppose you don't want all files, so you will do the git add and then give that file name. Okay, so that is the one file they created. Okay, now how to add in the staging environment? So I add that file and then I'm checking the git status. So I will see the green. So it is in my. So now I can do commit. I can do commit and then I can do push. But before pushing, I have to associate this folder, right? This project to the in the GitHub. I have to create a one repository. Then I will make it associated with that project. Okay. So okay. So I will be creating a one more file. Okay. To git add all command is there if you want all the file to, or git add dot, anything you can do to make it git status. So next thing is git commit. So git commit -m and then you are -m for the masses. But sometimes if you have done some changes, you can use git commit -a for append. Okay, suppose you have already committed file and then you are doing some changes. Then you can use git commit -a for append. So so I committed these two files. So two files I change it and these two files I committed. Okay. So now if I'm doing some changes, right? So this file, a new line I'm adding, vi index.html. So here I'm adding a one line. So if I do it, this file will come in the untrack git status. So again, it become red. So I can use git commit -a. So git commit -a. So it will not create another commit, right? It will be just add it in the this commit. Git commit. Okay, -a. Okay, one file is changed. Okay, so -a, -m. So we did. So now I'm creating a one repository in my GitHub account. So we have to create our own GitHub account. Okay, so it's a simple way, right? You can open github.com and you can associate your ID and user ID and email, and you can create your own account. Okay, so first I will going to create a repository because I have to push my code in one repository in the GitHub. Okay, so I'm going to create a new repository. I'm creating a public repository to push my code. One is public. If you want to add README file, you can do. Okay, otherwise you can create repository. So this repository is created. Okay. So now I have to use this repository, the whatever code I have to associate with my. So I have to add. Okay. So I have to add the repository. Okay, to get remote add origin, and I have added the repository. Okay. So now next is, so if I, so this is my repository. So now I will be a new repository. Okay. This is my new repository. So one command is there, git -v. So I can see that what is my target repository. So for fetching and pushing the data, we have the repository is associated. Okay. So I will be pushing my committed code. Is it main or master? So it is asking to my username. So I'm giving my username. Okay. And it is asking my password. So password is not GitHub password. It is a token. And this token you have to generate here. Okay. So I have already created token. So I'm not generating again, but I'm showing you how to create a personal access token, PAT. So how to create a PAT, you go to here settings, and settings here, you go to the developer setting, and here you can create a personal access token. So personal access token, you can create a token. So yesterday, okay, so you can create a token, but if you once you create a token, you can't edit it and you can't get it. You have to store it somewhere. Okay. Or otherwise you have to create a new token. Okay. So I have already copied my token. Yeah. So this is my personal access token. So I will use this token. Okay. So my code is pushed. So I can check here in my repository, my repo one. So my code is there. So now anyone can now git clone can do. So first I created a locally my project in the Git, and then I push to the GitHub. Okay, so my code is coming here. So now if I do changes, right, so I can do the changes. So I can do, okay. So if I'm doing further changes, so again, I have to push. So I have to add, so same process we have to do again, git add, and then, so suppose I'm adding further. So right now, this index.html, this is index.html, okay. So I'm adding that. If you are using SSH key, right, so you don't need to enter again user password, okay? So this is when you are not set it SSH key. I'll tell you how to create a SSH key and how to use in the GitHub, okay? So every time you have to give password. Okay. So if I'm refreshing this file, so I'm getting the new line, okay? So how to create SSH? If you go here and go to your settings, and here is a SSH GPG key, okay? So you can create a key, like new SSH key, and before, for that you have to do SSH keygen. So SSH keygen, you have to generate a new key value pair. So mine is already there. So okay, so there is this particular ID RSA file. If you go to cd/home ubuntu.sss, okay, so here is you can do cat this ID RSA. So this ID RSA, this one, you have to copy the content of this entire file, okay, and then you have to copy paste to here SSH key. So you can give some name, and here you can paste this key. So once this key is added here, okay, so okay, I do it again. Okay, so I okay, so now this ID RSA, this is a public key. So this key, I will copy. I do the changes. Software. I modify. is SSH key. Let me ask me. It should not ask actually, maybe restart something. So it will directly push your changes. Okay, so that is the use of the SSH key. Okay, so we can create a branch because the branch is useful, right? When we are working in the team, so everybody has assigned the different stories, right? So we are working on our feature branch. So there are the different types of branches are there, like feature branches there, or bug fix branches there, or release branches there. So we can create a different types of branch, and then we can work accordingly. And once the branch we create and we push our code in our own branch, so then finally we can merge request, pull request, we can merge to the master. Okay, so we can create a branch. So git branch. So git branch command will create a new branch. So we can create, and if you want to check how many branches are there, so we can check. But right now we are already in the master branch. We are not in this branch. If I want to switch in this branch, the git checkout command is there. The git checkout we can use to switch in the branch. And after that, I can check git branch. So I will be moved to the my new branch. Okay. So, okay. So some new changes I do and commit in this branch. So we can git add, and same thing we have to do. So we can follow the same. And GitHub also we can create a branch here in the repository. Okay, so here is so we write now one is a master branch. I think option comes here also. If we want to create our so git branch merge, like if we want to check out master and then we want to merge the code from our feature branch to master, so we have a command git merge. So git merge will be merging the your feature branch to the master. Or other way is like we can create a one pull request from our feature branch to merge to the master. So either way we can do. So if we have the permissions, so we can do, otherwise pull request we can create and someone will do the merging. Okay, so merge conflict is like whenever you are having the similar, like somebody also has done the changes, like somebody had checked out the code from your branch and done the changes. So we have to do the manual way merging we have to do, like this conflict will come. So we have to do the manual merge. Okay. So there are the git rebase. Actually, if you have to, you have some local changes. Okay, so you have some local changes and you want to take the remote changes. Okay, so there is a command git stash you can do, and then you can do git pull rebase, git pull rebase, and then you can do git stash apply. So what will happen, right? Somebody has the done changes. Okay, if I do changes here in my remote repository, okay, here I do some changes. Okay, so I'm committing. And I have done the locally changes also. So here, okay, this is not the. So I have local changes. Okay, so if you see git status, so I can do git slash. So my changes saved in the some buffer. Okay, so I have already my remote changes are there. So in which branch I'm right now? Git branch. So I have done the changes in the master. Okay, git pull. Okay, so now I have to apply my local changes. Git dash apply. Okay, now I have a conflict, so that I have to merge it. So I open the file vi index.html. So if you see here, so whatever the change is coming, this is the repo change is coming. This changes. So this changes you will be deleting. Okay, and then you can do final push. You can do. So now you merge it, your local with remote. So now local remote is merged, right? Now you can finally push it to queue. Okay. Okay, status. Okay, so I have to git add, git commit, final changes. Okay, and git push origin master. Okay, now I verify here. So I'm getting the whatever my local changes, now its final changes are coming here in the repo. Okay. So some other git revert, git reset. So those also we can do. Okay. So we have like pull, git pull. So git pull is always like if the updated changes I want to do git fetch origin. Fetch is basically taking a metadata. So whatever is the metadata, so we use git fetch. Okay. And git pull is like actual content you are fetching. So metadata you are using git fetch, and git pull you can do to get the actual data, actual code you can fetch. Git log also command. So git log -one line. So there are many more commands are there. Git diff is there. Okay. So we right now no difference. Okay. Git log -one line. So you can see the commits. You can see the history, right? Okay. So you can see these are some commands are there. Okay. And fork. What is a fork? So suppose some repository is there, and that repository you want to work. Okay, you have some changes in that repository, you want to do the changes, but that repository is not in your control. Okay, so what you can do fork, and then you can do fork. And once you do fork, the repository will be coming in your on GitHub account, it will come. Okay, so fork you can do any repository, you can do fork. Like, okay, I open any repository, and this repository, this is a 2.2K forks are done. So when I mean, right now, if you see, this is a W3 school test. Okay, when I fork it, it is coming to my account and create fork. So now this repository will be in my account. Then I can do the changes in this repository. I can commit the code. So it will not impact the original code. Okay. So now I have created a master of this repository. Okay. So this code repository. So this is basically the fork. Okay. So, okay, this is SSH key one, and git revert and git reset. Okay. So git revert and git reset. So sometimes we do the undo the changes, right? Like I have committed something and I want to undo. So what is the main difference in the git revert and git reset? So git revert is doing one extra commit whenever you do undo. So it will create a one more extra commit for every time you do undo. Okay. So undo is again a commit. Okay. So here the more commits will be there, right? If you have more frequently changes you are doing, suppose you are doing development testing. So you are having multiple like testing phases are there, right? So in that case, you should always use git reset. Okay, because git revert will be creating every time one extra commit. Okay, and that will make it more overhead. Okay, so git revert, right? You can get the commit ID. So find it like you want to revert to which commit ID. So git log one line, and then you can do git revert, and then you can tell the commit ID. So you can you can revert. Okay. Git reset. There are the different options are there, like git reset hard, git reset soft, mix, right? So you can do. You want to completely undo changes, git reset hard we can do. Okay. And here also we use the commit ID to reset. Okay. So git reset command, I'm giving the commit ID. So git reset. So when I'm checking here, so when I do git reset, so I change the commit ID here. So I want to get this version. Maybe right now in the repository. In -f, we can use some forcefully. Git accept. So git log one line if I check it. And if I see my index.html, branches, git full. Your changer or stash time. Right, so it is stash. What if I will be overwritten by some noise? Yes, I mean, oh, changes is showing reset changes. I think the changes are there with the local file. Okay. Okay, so whatever changes is there in the local, that is, it's not, it is going. This file is not changing. Actually, this file is not resetting. Once this file will reset, then the changes, updated changes will go. Okay. So reset will reset to the particular commit, you can reset. But it is showing here, git log. Yeah, it is resetting here. Okay, so this is all about the Git. Okay, so next is Jenkins pipeline, right? How to create a Jenkins pipeline. Okay, so how to install Jenkins. So I followed one link where you can like for installation and one pipeline. So we'll follow that to see how to create a pipeline. So installation is we can do. When this error is coming, this is a key error. Okay, so the solution of this one. When this error is coming, so we have to GPG, we have to add the key, whatever key is giving problem. Okay. Here to copy the key. Okay, after that we have to export. Same key we have to give. Will install. Yeah, now it's installing. And in the AWS account, I have to enable the HTTP port, because when I open the UI for the Jenkins, so the port is a 8080, but I have to enable the security group. So in AWS account, this is my server. Here, security, inbound rule, security group, inbound, edit inbound rule. So I have to add rule, all TCP. I have to add this rule. Yeah, I installed it for Git Jenkins service.
So one thing, right? One thing I missed, right? Now you are installing Jenkins, right?
Yeah, this is Jenkins. Yeah.
So what step you followed, right, for those to installing the Jenkins? I missed some steps, right? Can you please go a little bit up, if you don't mind?
This is just simply installing the key, and this is the package, and then the sudo install apt install Jenkins. Then we have to start the Jenkins service. Then the Jenkins service will be keep running. Okay.
Okay, got it. Yeah.
Okay, so some other error is coming. Okay, I already installed Jenkins. I showed that one. Okay. Because I did in the other server, it was working fine. So this is 59. So my public IP is my banking server. Okay, so what steps I'm telling you here, I will tell the steps. Okay, so here once once your Jenkins package is properly installed, then you have to open this URL, your IP and 8080. So mine is already installed. That's the reason I'm getting login. But in your case, it will come like this. It will be showing you this is the password location. So you have to find the password on this location, enter the password. After that, it will ask you to Jenkins suggested plugins, and then all the plugins you install, and you have to create your username, password, confirm password, full name, email. After that, you will be coming to this Jenkins login. So here in the Jenkins is a automation tool. Basically, we can create the pipelines here. We can schedule pipeline, and we can integrate with the GitHub also. So whenever code is committed in the repository, so the build and run the code I can do through the Jenkins. So Jenkins has the different types of projects we can do. Either freestyle project we can do, pipeline project we can do, or multi-branch pipeline, multi-stage pipeline. So different types of pipelines are there. So if I want to create my own project, so I will create a one freestyle project. Okay. So I can create a project. So any Jenkins project I have to create first. And here we have to use the GitHub. So I have to tell the GitHub location, right? So I have to use a GitHub. So I have to tell about my GitHub repository location. So which project I want to build. Okay, and I have to create a credential. So I have already created this credential. So this is SSH credential I created. How to create? If you do Jenkins, you create here. So it is going to the global credential. Okay, and here you have to tell the kind. So kind, if you are saying kind is either username password, so you have to set your GitHub user ID password. But if I don't want to set the GitHub user ID password, I can use SSH username and the private key. So here I can create a one private key, and here I can give the name of my user. Okay, like I'm connecting to the Ubuntu, right? So there I can give the Ubuntu and enter directly. Here I will store my SSH key. So here I will write it my SSH key. So whatever SSH key is in my GitHub, right? I will write that SSH key here, and that SSH key, and then I will add it. Once I add it, I will see like this. I have added. So I can create a new one. This ID, okay, I can say whatever you want to display it for that purpose. My key. Username, enter directly, add. I'm adding my SSH key. I go to Jenkins key. This oh, so this key I will use it in my Jenkins. Git repository. So this Git URL. I will copy this Git URL because I have fork also this URL. So this URL I will give here. Okay, and I have to go to the live save. My first build is done. This is simply just I build it. Okay, so it checked out the code from my repository and it built. Okay, and what further enhancement I can do in this pipeline? Okay. I have opened the steps. Okay, so this Jenkins all are installed. Okay, so next thing is when I'm just giving fork and I have done my SSH key I have done, and I will find this application location right in my server. So the Jenkins folder will be, this project will be checked out. So if I go here, I should check first Jenkins. Okay, here it is not created this. In this pipeline, we have done this one settings, this one we done. Okay, this one we have done the credentials. This one we have save it, and then we have, so we should get it and here it will be creating a workspace folder. machine I'm running it. Oh, this is the one. Okay, where you think is. Yeah, this is the one. Close it. Okay, so this is the one. Here is a Jenkins, all the project folder is created here. So CD workspace. Okay, we go inside this. So this is my project, Node.js app. So CD Node.js app. So this is my source code. Okay. So whatever Git clone, right? Everything is like checked out in my workspace. Okay. So what happened when I did the build? So it has done the pull the code from the GitHub repository, whatever Git URL I given, and it checked out and it is locally it is build it. Okay. So here now I have already installed my all this Node.js and Node.js commands I have to install. So if I install once this sudo apt install Node.js npm package manager, so this all I have to run it. Okay. So if I have done all these, so I can run my application, this node command. The node command will, but you should have the app.js file. So app.js file is there. So we can use this command. So my application, okay, it is throwing error. Okay, 8000 port is already in use. Okay. I just check my sudo docker ps because maybe, oh, okay, I have already run with the Docker. So I have to stop the container. Okay. That's the reason I'm not able to start. On the same port, I'm not able to 8000 port I'm giving for the Jenkins. So I'm not able to do with that. So I will Docker stop container ID. So this container ID. So actually I tried the same example with the Docker. So Docker stop. So I will stop container so that it will not listen on the same port. And rm command is for removing the container. Okay, so now I just run my command again. Node app.js. So my application is started. So if you see this running 80,000 port, now I can open the URL. So I can so my application is there. So this application is running simple like without Docker. Okay. So if I want to configure it with the Docker, right, I want to use container. Okay. So Docker has some certain commands, right? We have Docker is a containerization tool. Okay. We can create image and then we can create a container. So when we create an image, right, when we have to use the Docker file. If you see here, so one Docker file is created here. If I show you the Docker file, this Docker file, you will see the content. Like we are creating same whatever installation I did, npm install, npm run, and expose 8000. And cmd is the command to run your container. So I did it through through Jenkins I did, and I did all these command there, right? But now I'm doing with the containers. So if so I have to build first. Okay. So Docker build command is there to build the image, and then we can run the Docker run command. Okay. So here, when we go to the Docker, so first we have to install Docker, okay, and create a Docker file. And then we use the Docker build -t, and this will be build the Docker image. And we have to add the user also, our user too in the Docker group. Okay, so this is a Docker group we have to add, and we have to restart machine, and then we can run the Docker run command to run the image. And after that, we will see the same output, right? And how can we make it like frequently changes? Okay, so this is like if I want to automate through Jenkins, so I have to add in my same pipeline, I will add in the build step, these two command I will add it. Okay, so I will show you one pipeline I have done. If you see configure, so I have same repository is there. Okay, but I have to change here this credential, and here is a Docker command. So in execute, I am giving Docker build dot whatever my current directory. So it will build the Docker file and then create an image, and then it will run that Docker image. Okay, and create a container, and it will expose on the 8000 port. Okay, so when I apply save and I build it, so okay, so I'm able to see my Docker image is running. Suppose I want to integrate with the GitHub, right? Like sometimes, I mean, right now, whenever I'm doing the changes, it will be manually you trigger the build, right? You are triggering the Jenkins build manually, right? Whenever you commit code, and then you have to trigger. But I want to make it automate, like whenever I commit the code, so I will directly pull up the code from the GitHub. So there is a webhook is there. So webhook is basically you have to configure webhook in your GitHub repository. So I show you how can you create a webhook. So one webhook you have to create in the Jenkins, and by going to the settings. So if you go to GitHub repository, so GitHub you go here, and here is a settings, and here is a webhook, and this webhook I already created. So this webhook is I'm just telling about this is my Jenkins server. So my server URL is 383.99180. Okay, so this server URL is my Jenkins server is running, and 8080 port, this one. So this one is my URL for payload. So I will give this, and GitHub-webhook, this is the we have to give, and we have to change the content type application JSON, and then we will create a one new webhook. And whenever I'm doing the changes in the repository, it will automatically doing the build. And for this, what we have to do in our Jenkins job, we go to configure here, and we have to enable this one, GitHub hook trigger. So if you enable this checkbox, then only your Jenkins CI/CD pipeline will pull the data. Okay, and it will build the image. Same process it will do, but now it is automated. So Git webhook is basically like doing the auto build, right? So you are not doing manual build. Okay, so if I'm going to changes in my GitHub, okay, so I'm going to the view. This is the file. Okay, here I do some changes. Okay, now I commit this file. See, it is triggered. So pending, so it is the build is started. Build and deploy, right? It is so I will refresh my URL. So I will get my updated changes. This got failed. Okay, so this error is coming because I already run container, right? So you have to delete the container. You have to stop and delete container, remove container, then only you can create a new container, right? So it's giving the error. You have to remove or rename. So you have to do those things. So here I will check Docker PS command. The Docker PS command is showing what is the running container. Okay. And Docker PS -a is showing if any container which are running or not running, all will come. Okay. So here, if I want to stop the container, okay, so Docker PS, Docker stop. So if container is running, you can't remove it. You have to first stop the container, then you can remove. Okay. And how this setup is created, right? This so there is a Docker compose YML file is there. So Docker compose YML file, we are having all our containers, like whatever containers, like Docker compose YML. We are defining the services, right? And port expose we can give. Okay, and it is using Docker build. So I can remove the Docker RM command. Okay, now I do changes in the GitHub. Here. Okay, now it's successful. Now I refresh my code. So I have done these changes, right? Fix, okay. So this pipeline is working. So this is integration with the Jenkins with Docker. And we can create CI/CD. This is not CI/CD, it's a freestyle project. So when you create a CI/CD, so you will go here and give my CI/CD. So here you have to write a Groovy script, right? You can write, there is two ways are there, pipeline script. You can write your own Groovy script, or you can give the pipeline script from SCM. So you can give the path of your GitHub where your Jenkins file is there. Okay. So you can create CI/CD pipeline. So in CI/CD pipeline, there are multiple stages are there. Okay, clone stage is there, build is there, scan is there, like you are doing the quality checks, right? You would have test stage is there, deployment stage is there. So there are the multiple stages are there, and you can write a Groovy script, define all the stages by using the pipeline script. So you can write the script here, and that way we can create a CI/CD. Okay, multi-branch pipeline you want to create. So there is a, like you can use that item, right? Like create a multi-branch pipeline. So that way we can do. Okay, I will give this already this given link I given. So you can do practice with this and do the CI/CD pipeline. Okay. And one CI/CD pipeline with the, like one job is having the another job, dependent job. So we can define like dependency of the job. So separate job will be there. And we have to give, if this job is completed, then the second job will trigger. And second is completed, the third job will be triggered. So that is a multi-job like pipeline you can create. So there the multiple ways are there. You can do that. Okay. So Docker, you can all these tutorials I'm telling you where you can go and study. Okay, you can tutorial point, you can see Docker, Jenkins, okay, Kubernetes, all these tutorials you can see. If you understand how to create any one of the type application, like here I showed Node.js, but suppose I'm going to do Spark application. Okay, I found the one code for the Spark. Okay, so like a Spark Scala code is there, or Spark PySpark code is there. So same way you will create a pipeline, right? That is also the project, right? Maven project. Okay, and that project, so that project you will be like you have like a Spark Scala project. So here you have source code is there. So you are creating a target and you are creating a jar, right? So everything is done by the Docker build command. The Docker build command will create a jar in the target, and then you will do the Spark submit command to deploy your jar, and then you can see the result. Okay, so that way we can see. And if you want to see the tutorial, right? So like Docker Docker Hub is a repository. Suppose this image I want to store in our Docker Hub repository. So I have to have a login in the Docker Hub repository, and then I can use Docker login command. And Docker login command, I can give my username, password, and then I can Docker push in the repository. I can push the image. Okay. And whenever you want to, so image or container, what is the difference? Image is a logical and container is a physical part. Okay, both are same. The only difference is, like, if I say something is a running mode, that is the container. Okay, so when I say when something you just pull it, that is image. Okay, but when you do the Docker run command, then it becomes container. Okay, so when you say the Docker images, so it will show you list of all images, right? Docker images. Okay, so all these images are there, but how many are containers? So if I say Docker PS, only one container. Okay, so this way we can like create image and get the image, and then we can create the containers. Okay. Okay. Anyone has questions? So there are some more topics are there. Okay, like Terraform is there, and Kubernetes is there. So all these are the advanced concept. Like you can have the Docker knowledge, you can go next for the Kubernetes. So same thing, like whatever the deployment and orchestration we are doing, like using the Docker has some limitations. The multi-node cluster environment we cannot create with the Docker, but we can go with the Kubernetes for the orchestration. We can create services, pod, replicas, ingress, egress. So there are many more concepts are there, and everything is through the YML. Like we have to create it YML. If I want to create a service, so I have to create a YML and I have to apply it. Okay. And then if I want to deploy any service, so I have to create a YML for the deployment. Okay. So there are the different types of deployment strategies are there, and there are the blue-green deployment is there, canary deployment is there, recreate deployment is there. So like some deployments, like if you want to don't want to backup is like kind of one you want to do. So there is a blue-green is there, like one is a blue and green, right? So when your actual deployment is done, then you will shift it. Okay, so those are the concepts are there in the Kubernetes, and the Terraform is like infrastructure as a code, right? So entire this AWS instance we created manually, and we set up everything in the instance, right? We are doing everything there, right? We are installing Jenkins. So if I want to this complete infrastructure setup I want to do, I can use the Terraform. So Terraform is basically having one is a main.tf and one is a variable.tf, output variable.tf, and modules we can create. So suppose you want to create instance and you want to apply security, BPC, and then you want to create a Lambda function, or you want to anything you want to install, you can everything configure through the Terraform. So Terraform, you can define modules, and in the main.tf, so if I show you, I have done for some practice how to create a Terraform, like a Lambda and the API gateways. Okay, so you should need access key, secret key, and your reason, which reason you account is there, like in which account reason you are going to do. So then you can define access key, secret key, so it can access your AWS account, and you have to provide the provider. You have to provide the provider, and that provider will be AWS provider. Okay. So like this, different like main tier. So here you are defining a region, access key, secret key. Suppose I'm going to create a EKS cluster. So I'm just giving a EKS cluster information like name of the cluster, what is the role. So one okay, so one policy like user policy we have to create in the IAM role. Okay, and I can use in EKS cluster, I can define that role ARN. So ARN is a unique resource identifier number, right? Like that can be uniquely identify the resource on the AWS account. And other properties we are giving the region, access key, secret key. So that will allow to.
So what is the
access
main purpose of the Terraform? Sorry for interrupting. What is the main purpose of the Terraform?
Terraform is infrastructure as a code service. Okay, suppose it's independent to the cloud provider, and it is you want to create 100 instance at a time, right? Okay, so one way is like you do manually in AWS account, and you create AWS instance, you create, and then you apply security VPC. If all these things, if I make it configuration in my Terraform file, I define those variables, right? I want to define VPC security group. So I can apply it my AWS 100 instance. So I can define how many instance I want. It will create everything from, it will access your AWS account with the access key, secret key, and whatever configuration you give, it will create it over there. And then you will get not only for AWS, Azure and GCP. The only thing is you have to change the provider. So provider is AWS. And if I'm using the provider is Azure, so I have to choose the like Azure credentials we have to use, right? And GCP, if I'm using the GCP credentials, I have to provide to access the account. And if I want to create a EKS cluster, Elastic Kubernetes Service, right? So I want to create a EKS cluster. So it will create a EKS cluster. Okay. So manual way is there, or this is a configuration like as a infrastructure as a code Terraform can create. Okay. So there are many more many more Terraform scripts we can create. Like we can say like, okay, I want to copy the data from the S3 bucket, I want to automate, right? Whenever the data comes in S3 files, I want to move it to the dev environment to QA bucket. Okay. So that kind of automations I can do with the Terraform. In AWS, there is a cloud formation is there. Cloud formation doing the same thing, but cloud formation is a proprietary to AWS. You can only use for AWS, and AWS like cloud formation has a stack, right? You can create a stack there, and then you can create a template either through JSON or you can create through JSON or YML. Okay, both options are there. So here we are creating, this is multi-cloud, right? Any cloud you can create, for any cloud you can create the script you can create. Okay, the Terraform script you can create. So if I want to do some task in the notification, like SNS notification task I want to do. So suppose I'm just defining here in my main.tf, I define the DynamoDB. I'm saying I want to create some resource, the table name, and I'm telling about the hash key or the columns I'm defining, and I'm telling about my column names I'm defining item. This is like basically individual fields I'm telling, right? How many fields are there in my that particular DynamoDB table? All these resources I'm telling through the this AWS provider. So here after that I'm defining the resources. So I want to create a DynamoDB table through Terraform. I can do that. Okay. So in the Terraform, when you run the command, so there is a Terraform init. So first you do the Terraform init. So when you start, so you have to do Terraform init command. So that will be doing the initialization of your script. And Terraform, next is Terraform validate you can do if you want to validate your script. Terraform plan and Terraform apply. And finally, if you want to destroy, Terraform destroy. Okay. So it will do the step by, this is the life cycle methods. Okay. So Terraform init, validate, plan, and apply, and destroy. So destroy will clean all the resources, whatever resource it has created, and you don't want to keep it, you can just use a Terraform destroy. So it will do all the resources cleanup, it will do. Okay. I'll send this this Terraform scripts I have, whichever. Okay. Okay. So how you can do. So it's just command line. Once you have configured like you have in the like this access key, secret key, to just you copy paste here, and then you command line terminal, you just do. So first you check it, because Terraform you need to install first in the locally. So Terraform. Terraform. So like this is doing initialization. So if access key, secret key, if it is not matching, right? So some error, it is not able to make a connection. So it will give me the error. Okay. So this is for SNS notification. Like once I create my table, I want to send the notification. So I can configure the simple notification service. So I can send email, right? Okay. So if any error will be there, it will be showing the error. Okay, I'll share the script so you can try it out. Anybody has any question? I'll share the recording, and you can follow this Jenkins and Docker.
Yeah, my question is this thing they are very high level. So are we going to get to learn more and deep dive into it during your section?
Yeah, I will do that. This is just I shown because DevOps we have to do like after the manual installation, right? Okay. But initial DevOps knowledge is important, right? Whenever you are working with the repositories, right? So you should know Git, Jenkins, Docker. So these three you should know, like for any time, like you are doing an installation or anything, right? So you can do the same thing. Whatever you do manual installation, you can do with the so Docker I will teach, right? Not very expensive as a like a DevOps guy, but I believe, right, some Jenkins Docker Kafka pipeline. Okay, so I have a streaming pipeline. I have already done some examples. Okay, like this kind of examples: Jenkins, Docker, Kafka, Cassandra. So any number of tools you can do the you can do. So I have one link. I followed one like complete Spark Kafka streaming pipeline on the Docker container. So we write a compose file, and that compose file we define all containers, like Kafka container is a one, and the Cassandra is there, and the Spark is there. And then finally, once we run this compose file, and then we go to this compose file, we run it. And once compose file we done, we will see this is a compose file. So one is a Kafka, Zookeeper, okay, Cassandra. Okay, so once the compose file done, right, our all containers will be separate container. So I will go to the Kafka first, and I will do the same. Like I will create a Kafka topic, okay, and I will start the producer. I will do the same thing whatever I do manual, right? But here in the containers means I have to go inside the container manually. In the container means in the machine, right? So and when I go to the Cassandra, I will create a database, I will create a table. And finally, once I've done all these activities, then after that, I will I will do the Spark submit in my Spark container. So my job will be communicating. So this entire flow will be running in the container. The only advantage we are getting using the containers is like we are not doing the manual installation completely end to end, right? Okay. But we have to learn that also. Like Kafka, Spark, Cassandra, manually we are doing. But containers means like when we are working in the containerization environment, so there we should know how to communicate, how to check logs, how to stop container, how to run container, all these things. Okay. So these things will be definitely like if you have started something, then definitely you can deep dive in the DevOps is very, very in depth, right? There are many more tools are there like monitoring tools like Grafana, Prometheus. So all those are not that much extensively needed for the big data engineer. But I believe like if you are good hands-on, right, that will be good, right? Okay.
Okay, thank you. I look forward to the course starting next
Okay.
weekend.
Thank you. Yeah, thank you. Bye.